हरिः कर्ता
Hooray! So Prasad is pretty happy because he got to understood everything about association rule mining. So now he just wants to apply the knowledge that he has gained into the data set and to gain profits. Let's see what's next in his journey. So now he got to know everything. Now the next question that pops up in his brain is, what is the goal of association rule mining? Why do you want to do association rule mining? So the goal of association rule mining is to find the meaningful rules within a given set of transactions. In Prasad's case, customer purchases customer purchases in Prasad's grocery store. So these rules have specific thresholds for support and confidence. The support threshold we also call it as a min sup. The support threshold min sup determines the minimum level of occurrence required for an item set or rule to be considered significant. So if support of any item set or any association rule greater than or equal to min support threshold value, then we consider that item set or that association rule as significant. So the support threshold determines the minimum level of occurrence required for an item set or rule to be considered significant. Similarly, we got the confidence threshold. So if confidence of an item sets or association rule, if the confidence of an association rule greater than or equals to minimum confidence threshold, then that association rule can be considered significant. That the confidence threshold sets the minimum level of reliability or strength of the rules. So the Prasad's objective is to identify association rules that meet the thresholds. By doing so, he can discover valuable insights about which items are frequently bought together by his customers, leading to improved decision making in terms of store layout, product placement, and marketing strategies. So now how he knows what is the goal of association rule, but how to execute that association rule mining. How to execute the association rule mining. The basic and rudimentary fundamental approach is brute force approach. Brute force approach. The brute force approach the brute force approach to association rule mining involves listing all possible association rules, computing the support and confidence for each rule, and then pruning, or you can call it as removing the rules that fail to meet the min sup or min confidence thresholds. However, This approach becomes computationally prohibitive and inefficient as the number of items and transactions increases. So if you see that brute force approach, it's a three-step: list all possible association rules, then compute the support and confidence for each rule. Support is probability, confidence is your conditional probability. Then third step: prune or remove rules that fail the minimum support and minimum confidence thresholds. But the issue is computationally prohibitive. If you have a data set of 5 or 6 transactions, it's pretty fine. If you have 150, still it's okay. But if you have a 50, if you have 5 lakh 40,000 data points or 5 lakh 50,000 transactions, then it will become computationally prohibitive. Maybe you require a quantum computer. You require a quantum computer to make this computationally eligible. So that's what is a brute force method. So in Prasad's grocery store scenario, considering all possible combinations of items and calculating their support and confidence for every rule would be time consuming and impractical. The brute force approach quickly infeasible due to the sheer number of possible rules. And if you still want to do the association rule mining with brute force approach, then you have to design your quantum computer for that. Then only it's possible. Okay, so to address this computational challenge, more efficient algorithms and techniques are used in association rule mining, such as a priori algorithm. Okay, but before we get into the a priori algorithm or that sort of algorithms which make which actually fulfill the requirement to do the association rule mining. But before that, let's take a small example. If you have only 5 transactions, then how can we use a brute force approach? So this, the left side that you see on your screen, uh, is your transactions data set in Prasad's grocery store. Transaction 1 to 5, total 5 transactions we have. So we have taken some 5 rules, basically milk, diaper, tend to beer. And for this rule we have calculated then so initially uh, we have uh, initially we have written all the possible association rules. Then we have to compute the support and confidence for each rule. So that's what we are going to do. For milk, diaper, tend to beer, the support is 0.4 and confidence is 0.67. So milk, beer, tend to diaper, confidence is 1.0, whereas milk, tend to diaper, beer, the confidence is just 0 0.5. And this is the evaluation metrics that we got here for the respective rules, respective possible association rules. So finally, the observations from this are: all the above rules are binary partitions of the same item set, milk, diaper, beer. Rules originating from the same item set have identical support but can have different confidence. Thus, we may decouple the support and confidence requirements. So, by leveraging these techniques, Prasad can discover meaningful association rules, optimize his business strategies, and provide a better shopping experience for his customers while avoiding the computational challenges associated with a brute force.